All right, so what we're going to do is we'll take and go through each of the equations. Now, each one of these is really simple math. We're just multiplying and dividing and using exponents. That's it. So it's super easy math. I feel kind of silly up here doing this, but I know that historically, I go, hey, does this help? And everybody's like, yes. Yeah. So we'll get started out. We'll start. Going to do this. Okay, I've resolved my technical difficulties. Yeah. So let's start off with the direct square law. And remember, what's the other names for direct square law? What was that? Yeah, exposure maintenance formula or density maintenance formula. Now, as we talk about each one of these equations, remember the whole purpose of these equations is to maintain IR exposure. So all we're saying is you change this and you want to maintain the exposure. What is the new mass going to be? So we have in this equation, we have new mass equals old mass, or we could say mass 1 times distance 2 squared for distance 1 squared. So if we take a look at this, if we have taken and go mass 1 equals 10 mass, and distance 1 is 40 inches, distance 2 equals 50 inches. So my new mass equals 10 mass times 50 inches divided by 40 inches. Do we have some calculators out? So our new mass equals 15.6 mass. So now we just make that adjustment for the change in SID, and we have a comparable exposure right there. That's pretty simple, isn't it? Now, are we going to have a mass station of 15.6? No. I'd just go to the closest mass, which could be 15, it could be 16, depending on the machine. It could be 17.5. Okay, so let's say we have mass 1 equals 40. Distance 1, this is just the wrong height right here. Distance 1 is 40 inches. And distance 2 equals 32 inches. Okay, so we're going to say new mass equals 40 mass Now, here's how I think about this. If I go from 40 inches to 32 inches, to maintain IR exposure, does my mass need to be increased or decreased? We need to decrease it. That is exactly true. So I just set up the problem like that. 40 inches squared divided by 32 inches squared. Now, do you need a calculator with, no, mistake. I headed my head backwards. I just did that dyslexic thing. Okay, we're going to take this times 32. Even while I was writing it, I'm going, this doesn't feel right. 40 inches squared. Now, you don't need to have a calculator with exponent capabilities. Also, you can actually just take 40 times 32 times 32 divided by 40 divided by 40, and you can do it that way because it's the same thing, right? And so the new mass is going to equal what?
25.6.
There you go. Just like that. You know what I think happened? Somebody dropped this, is what happened. Any questions on direct square law? Straightforward stuff. Straightforward stuff. Let's look at grids. I'm tired of green. Okay, so with grids, you're going to take mass 1 times new over old. We could say grid 1, grid 2. Now, what the grid conversion factors are telling you is if I go from no grid to a 12-to-1 grid, the 12-to-1 grid is going to absorb 5 times the amount of radiation as no grid at all. So that's what we're compensating for, is the absorption of our remnant beam. So have you all memorized the grid conversion factors yet? 5-to-1 is 2, 6-to-1 is 3, 8-to-1 is 4, 12-to-1 is 5, and 16 or 17-to-1 is going to be 6. Okay, so you'll want to memorize that. When you take the registry exam, we keep things simple here as far as for math purposes, because these are rules of thumb. But you might take it at the registry exam, and it would say you go from no grid to using an 8-to-1 grid with a CGF, grid conversion, GCF, grid conversion factor. And they'll say 8-to-1 grid, GCF 3.84. Okay, so they'll give you the values. So if I have mass 1 is 20, and grid 1 is none, What's the grid conversion factor for no grid? 1. And then grid 2 is an 8-to-1. Grid conversion factor for that is 4. Okay, so then I'm going to take 20 mass. I always think of a gift card, Christmas time. To Mom from your favorite son, Don. Okay, so we have an 8-to-1. So it's, and then a 1. What did I do there? Golly. My brain farted. Just like that. Do you agree? So what just happened to my patient dose? It just went up by a factor of 4. Yeah, because mass is a direct relation with patient dose. What you have to remember is the amount of radiation that we're actually using is very low in comparison to other studies. It's, I want to say, a chest CT, you get it's equivalent to, now I'm not going to say it because I have to look it up. It's either 100 or 1,000 chest x-rays. What's that?
It's a lot.
Yeah, it's a lot. Okay, so if we have mass 1 is 40 mass, and we have a 12-to-1 for the original grid conversion factor of 5, and then our new grid is 6-to-1. That's going to be a 3. Okay, I'm going to take 40 mass. Times what I look at. I'm going from a 12-to-1 to a 3-to-1 or a 6-to-1. So I am going to have a lower mass. Would you agree? It's less efficient. So I'm going to take this times 3 divided by 4. And that's going to be,
It's 40 mass to begin with, not 4.
yeah, boy. I'm brain farting again. I must have eaten beans in my dreams last night. There we go. So it's 120 divided by 5 is going to be, what, 24 mass? And there you go. And we've just maintained our exposure. Let's do part thickness. Okay, and we're going to do fixed kVp. Now, when I say fixed kVp, this is the adjustment for part thickness only. Okay, with fixed kVp, what am I going to be adjusting? Mass. So if we have, for every centimeter increase, you're going to take and increase mass 20%. That's exactly correct.
This doesn't pertain to this equation, but if it's KVP you're changing, isn't it just add 2 KVP per centimeter?
Or subtract 2 kVp per centimeter, yes. We'll do that in just a second. And for every centimeter decrease, we're going to decrease mass 10% per cm. Okay? So let's say that we have 20 mass. And we have part thickness 1 is 14 cm. Yeah. And part thickness 2 is 17 cm. So the part has swollen. I'm going to take 17 cm minus 14 cm equals 3 centimeters. And take 3 centimeters times 20% per centimeter equals 60%. So then I'm going to take 20 mass, or I'll take 60%, or I'll do it this way, 20 mass, yeah, times 0.6. That's going to be 12 mass. Now I take 20 mass, plus 12 mass equals 32.
Math savvy, you can skip a step and do multiply 20 by 1.6.
That's right where I'm going. Yeah. So it's Orville, right? Okay. What he's saying is if we take 100% plus 60% equals 160% divided by 100 equals 1.6. So if you just take that 20 times 1.6, you're going to end up with 32 as well. I like to go long route first. I've lost students right here so many times you wouldn't believe it. Yeah. Any questions on that one? I wish this board was a little larger, but oh well. So let's do another one. This one is going to start off with 30 mass. And we start off with 20 centimeters. And we end up with 18 centimeters. Now, I can't imagine where that would ever be, you know, as far as as far as a single patient, you know, I guess I could say, pre and post liposuction, you know, or tummy tuck or something. But, you know, in reality, what we're adjusting for is we say, hey, my elbow is 10 centimeters and it looks like her elbow is 8 centimeters. I'll take off 40% or 20%. Okay, so we're comparing anatomy. So we're going to take 18 cm minus 20 cm equals a negative 2 centimeters. We're going to take negative 2 cm times 10% per cm equals negative 20%. Okay, then we're going to take 30 mass and we'll take minus 0.2 times 30 mass equals a negative 6 mass. So then we would take 30 mass minus 6 mass equals 32 mass.
24.
Oops. I was thinking about my detail. 24 mass. I was thinking about what I'm going to be doing for my detail presentation in just a little bit. Do you have a hard time concentrating?
We're soft.
All this week?
Yeah.
The last 5
Every
weeks.
time I try
That's not even a question.
That's not even a question. Have any of you hit cognitive overload yet? Where it's kind of like it's bouncing off? That's a normal feeling right now at this point in the term. Okay, so just know you are not abnormal. For those of you that have watched Young Frankenstein, you know exactly what I'm talking about. The abnormal brain. But okay. So we worked 2 part thicknesses there, right? Okay, so let's do another part thickness. And it's going to be variable KVP. So for CM increase, we'll say 1 CM increase, you would take and add 2 KVP. And for every centimeter decrease, you would subtract 2 KVP. Oops, per centimeter. And now you want to know what I'm thinking about? I get shrimp Alfredo for dinner today. Yeah. I'm amped. I have a nice burrito for lunch today. Yes, I like to eat.
Normally, haven't you eaten your lunch by now?
Normally, but I got kind of tied out.
I'm just checking on.
Yeah, thanks. So if we have a KVP1 is 70. And part thickness 1 is 15 centimeters. And part thickness 2 is 18 centimeters. Take 18 centimeters minus 15 centimeters equals 3. And we're going to take 3 centimeters times 2 kVp per cm equals 6 kVp. And we're going to take 70 kVp plus 6 kVp equals 76 kVp. There you go, right there. Any questions on that one? Should we do a thickness decrease? Okay. Okay, so we have, and I don't have one written down here, so let's say we start off with 80 kVp. And we have a part thickness of 22 cm. And then we end up with 18 cm for part thickness 2. We're going to take 18 centimeters minus 22 centimeters. We're going to end up with a negative 4 cm. Take negative 4 cm times 2 kVp per cm equals a negative 8 kVp. So then I'm going to take 80 kVp minus 8 kVp equals 72 kVp. Just like that. Yeah.
Isn't the decrease, is it supposed to be multiplied by negative 2 kVp?
It's negative 4 times 2 kVp per centimeter.
What about the part that you wrote before on the left-hand side, the 1 centimeter decrease, there is 2.
It's, you subtract, you add here, you subtract here. And so what I do is and know what I did. Oh, no, we're good. What I did was solve for negative centimeters.
Yeah.
And then I take the negative centimeters times 2 kVp.
Okay.
Could work it the other way. And that's where we get the negative 8 kVp.
Okay. So you just multiply by 2 any.
Mm-hmm. Mm-hmm. Yeah. Okay. I guess I could write, I wonder if I can write. No. Okay, so relative speed or relative speed value. Here's what you're going to want to memorize in our lab. The DR system is RS 400. CR system, which we haven't played with yet, is RS 200. The Fuji film cassette, the regular cassette is RS 300. And the extremity is RS 100. Okay, so what we're going to do is take mass one times the RS1 divided by, oops, yes, RS2. This is old speed, this is new speed. Now remember, when we talk about these, let me get this written down here. So if we start off with a mass of 5, and I have RS1 is 400, and RS2 is 200. Now, remember, the higher the RS, the more sensitive the image receptor is to X radiation. So what we're saying is that an RS 400 is twice as sensitive to X-ray exposure as a 200, okay? So what are we gonna do? We're gonna take new mass equals 5 mass. Okay, our original one is 400. Our new one is 200. I'm going to set this up this way here. Old over new. And we're going to end up 5 times 4 is 20, divided by 2 is 10 mass. Right there like that. Is that what everybody got? Okay, so let's just do another one. We start off with 10 mass. Okay, and RS1 is 100. And new is going to be 400. So we'll take 10 mass times, do we need a higher or lower mass to compensate for this speed change? We need lower, don't we? Mm-hmm. So we'll go 100 over 400. Equals 2.5 mass. Right there. For recording purposes, I'll circle it. So none of those are difficult, are they? It's just remembering there's 2 ways you can do this. You can memorize the equations, or you can take and reason it out. You know, so as newbies to this, I would recommend memorizing them, you know, if that's the way you remember it. Yeah. Would you like to work a big problem now? Okay. So I don't like black. So we start off, we have a patient that comes into the ER, and we shoot a humerus. It's in the department. We shot it. What I visualized in my head is I've got the patient, he's walkie-talkie, and we, put him up to the wall bucky. Okay? And so we get a 40-inch SID. We have a 12-to-1 grid. We use DR, so we have RS 400. My 4's got a ponytail on it. Part thickness is 20 cm. They take him up to surgery, they reduce the fracture, and patient, they call you up to recovery to do an image, and I can only get 45-inch SID. It's a portable grid that's an 8-to-1. I use CR, it's an RS 200. And part thickness is 23 cm. And then we have a wet plaster cast. Okay, so new mass. Equals 5 mass times 45 inches squared divided by 40 inches squared. What's that come out to? 6.3? We'll just go 6. How's that? 6 mass. Going from a 12-to-1 to an 8-to-1, do I need a lower or higher mass? Go from a high efficiency to a lower efficiency. I need decreased mass. Okay, so we'll go, we're going to an 8-to-1, which is a grid conversion factor of
3. No.
4. Mm-hmm. And 12-to-1, 5. And we have 24 divided by 5 is going to be 5.3. So we'll just say 5 mass. Okay, we're going from a fast system to a slow system. So we're going to go 4, take it times RS 400 divided by RS 200. And that's going to be 10 divided by 1. What I did was just simplified this fraction in my head. So it's 20 divided by 2, and we end up with 10 mass. Way. Okay. Part thickness. This is fixed kVp. So part thickness, we're going to take 23 minus 20 equals 3 centimeters. We'll take 3 centimeters times 20% per cm equals 60%. So I'm going to take that 10 mass times 1.6 equals 16. Correct? Mass. We have a wet plaster cast. What do we do with a wet plaster cast?
Add 5 kVp to double the mass.
Double the mass and add 5 kVp. And we have 75 kVp. Plus 5. So with all these variables here, we come back, we shoot 80 kVp at 32 mass, and we're good to go. Right there. Yes.
I don't know if this is a stupid question.
No,
but,
yeah, ask away.
So what do you mean by fixed KVP then, if you just like change the KVP?
That is not a stupid question. That's a good question. It comes up every year. Remember, when we talk about fixed or variable KVP, that is only for a change in tissue thickness. In other words, even with a fixed KVP system, I could say, hey, I want a lower energy beam, and I could change my KVP and compensate with mass. Does that make sense?
Yeah.
So it's only for tissue thickness change.
Okay.
Mm-hmm. Any other questions? No? All right. Well, that's it. We're out of here a couple minutes early today.